Alright, for those of you who saw Chapter 7, Number 15, Part A, you may have been a little confused about the ending where I said, and that's it, we're done, because I didn't plug in 34. If I had plugged in 34, I would have found out that. Let's get this going. Tan of 34 degrees equals with the proper significant figures 0.67, and that's the coefficient of static friction, to make sure that that's the coefficient of static friction needed to make sure that the snow doesn't slip. However, what if the snow does slip? This is part B. They give us the coefficient of friction. It's kinetic, and it equals 0.20. They say it goes a distance of 6 meters. And so it's asking for the final velocity. Well, the best way to solve something like that is to find out what the acceleration is. Okay. Really, this is the exact same problem as part A. The difference is, for finding the acceleration, the difference is that the force of friction, the force of gravity in the x direction minus the force of friction, we'll use the K instead of static, use kinetic, will equal ma instead of 0. Because here it's actually accelerating now. Since it has acceleration, it doesn't equal 0, it equals ma. The sum of all the forces equals mass times acceleration. Okay. We don't know the mass. We are trying to solve for, in this case, the acceleration. So let's rewrite this. mg sine theta minus mu k for kinetic, and then the equivalent of the normal force is the mg cosine theta, the force of gravity in the y direction. ma. Okay. Mass doesn't matter. So g sine theta minus mu k g cosine theta equals a. It's good to factor it out. Minus mu k cosine theta. All right. Now that we have acceleration, or a formula for the acceleration, if you plug in the numbers, you'll find that A equals 3.8 5517 6812. This is a 6. 1, 2 meters per second squared. Okay. To find the velocity, you can use this formula. Alright. So the initial velocity was 0, which is nice, so that the final formula comes out to 2a delta x. You plug the numbers in, and you get 6.801. Now for the acceleration, I plugged in this whole thing to give me a more precise answer. 26404 meters per second. And keeping it in significant figures, that's 6.8 meters per second. That was a fun M. Okay, final velocity. Okay. Concludes that part of the problem.